Hello everyone, in today's video I will be going over these 5 examples. To do this and to understand it, you have to have your spinner filled out, and specifically we're going to focus on these 2 sections, the central angle section and the inscribed angle section. So let's look at number 1. We have angle QRS here. We know it's 46 degrees, and they want us to find the measure of arc QS. Again, I recommend color coding for this section. So we have QRS here. And so then this is the angle, and then this is the arc that goes with it. So this is a central angle. And we can tell, if we go to our circle here, we can tell it's central because the vertex is in the center of the circle. So this is kind of what ours looks like. For the most part, it looks just like that. So the vertex of the angle, that's the middle letter, QRS, R. That's in the middle, it's on the center. So it's a central angle. And this says that the measure of the angle equals the measure of the arc. So whatever the arc is, the angle is, and vice versa. So, since our angle is 46 degrees, so is our arc. So the measure of our QS is 46 degrees. And that's it. All right, number 2. Here we have angle CFE. It is 37 degrees, and they want us to find arc CE. So again, color coding really helps here. Really helps some students bring that angle out and see what it is visually speaking. There's the angle, and then your intercepted arc is in between the points of the angle. So it's that bit there, and that's what we're looking for. So it goes with the angle. So based on that, this is not a central angle. As you can see, the vertex is not at the center. The center point is D. The angle is not even a part of that. Here, the vertex F is on the circle. We call that an inscribed angle. So the vertex is on the circle. We do have that going on here. And this is the relationship. The inscribed angle equals 1/2 of the intercepted arc. So the angle is half of the arc. Well, in this case, we know what the angle is already. We know the angle is 37 degrees. So if the angle is half of this, we have to make this number bigger. How much bigger? We have to double it to get CE. So to find CE, we just do 37 times 2. Oh, hang on. Let me also label this. This is an inscribed angle. Now that we know. So then we take 37 times 2. And we get, is that 74? I believe so. Yes. 74 degrees. So our arc here is 74 degrees. So the measure of arc CE is 74 degrees, and we are done. So I just want to clarify. The angle is half of the arc. So if we had the arc already, we would divide this by 2. We take half of it to get the angle. Well, since we started with the angle, we actually had to double this to get the arc. So that's why we went that direction. All right, let's look at 3 and 4. I know these problems look a little scarier. Again, this is where the color coding really helps. So we know that this angle here is 35 degrees. That's LMJ. And we want to know JKL. So let's start with the angle that we are given. So this angle right here is 35 degrees. And its arc is LJ. So, this angle, we look for the vertex, which is M. It's on the circle. That makes this one an inscribed angle. And since it's inscribed, again, the angle is half of the arc. Since we know the angle, and the angle is half of this, we need to double our angle in order to get back to our arc. So if we had the arc, we divide it by 2 to get the angle. To get back to that, we multiply by 2. So this arc is 35 times 2, which is 70 degrees. So this arc here is 70 degrees. Now our other angle, JKL, the one we're looking for, don't know how well this will show up. Okay. This is the angle we are looking for, and it still goes with JL, you'll notice, because that is the intercepted arc of the angle. The points are J and L, so this space in between. Notice that these overlap, so they share this arc. That makes it really nice to be able to find the measures of both angles without much issue. Now, JKL is at K, that's the vertex, and K is the center of the circle. So this is a central angle. So the blue is a central angle. And remember, central angles are the same as their intercepted arcs. So since our arc is 70 degrees, so is the central angle. So the measure of angle JKL is 70 degrees. I'm going to go ahead and write that in as well. So now we know it is 70 degrees. It's also nice to take a moment because we do have a direct comparison between the two angles here in case you were struggling to see what's different between the two. If you think about it, the inscribed angle is like if we took the point K here, the central angle, and we pulled it back to touch the circle. When we do this, we are taking this angle, we're pulling it, we are making a wide angle, we're making it more narrow. This is why the angle itself, it becomes smaller from here to here. So in the middle, it's equal. But on the actual circle, it is much smaller. It's actually half the size. That's what you can imagine we're doing, and that's why the inscribed angle is smaller than the arc that it intercepts. Let's do another one of these, a slightly more difficult picture. Number 4, we know that JKL is 82 degrees. So it's this angle here, which goes with this arc. And we want to know JML. So the angle we're looking for is this one here. So let's start with the angle that we are given. JKL. We do know that it's 82 degrees. If we look here, the vertex is at K. That's the middle letter of the angle name. And it is at the center, which K is also the center of the circle. So this is a central angle. Since it's a central angle, our arc here that I've highlighted, the intercepted arc, is also 82 degrees. It's going to be equal. And the goal is to find the measure of angle JML. That is the angle we're looking for. Now JML, the vertex is M. It's the middle letter in the angle name. And the vertex is on the circle itself. It's actually on the circle. That makes it an inscribed angle. Now this time we know the arc, which if we look, the angle touches at J and L. So the intercepted arc is the space between those points. Again, they share that space here. So this arc is what's intercepted by the angle. Since we actually know the arc is 82, and looking at our spinner, the formula for this is that the angle is half of the arc. If we know the arc is 82, then half of that would give us our angle. So for JKL, we would do JML, 1/2 of 82, which is going to be 41 degrees. So our angle in here is 41 degrees. That is the measure of angle JML. All right, we have one more problem to solve. This time we know that our arc GH is 118, Our angle GFH is 11x plus 29. And for this one, they want us to solve for x. So one more time, I'm going to highlight this angle just to draw attention to it, make it more obvious what we're looking at here. And then this is our arc that goes with it. Again, you find where the points where the angle touches the circle, not the vertex with the other two. And then the space in between them, that's going to be your arc. Okay, so we need to first ask ourselves, what kind of angle is this? That's going to be what you need to ask yourself on all these problems when we get to our test especially. What kind of angle is this? What am I looking at? So our vertex is the middle letter of the angle name. So we have GFH, F being the middle letter. The vertex is on the actual circle. Since that is the case, this is an inscribed angle. Since it is an inscribed angle, we know that the angle is half of the arc. We already know what the arc is. It's 118. So let's take half of that to figure out what the actual angle is. So for this angle, we have 1/2 of our arc, which is 118. Again, this all comes straight from the spinner. I will show you one good time. Inscribed angle equals 1/2 of the intercepted arc. Intercepted arc is this bit here, and half of that is going to be the angle. So 1/2 of our arc, which is 118. And that will be, I believe it's 59. Yes, it is 59. So we know this angle is 59 degrees. We know that for a fact. And we also know that it is represented by 11x plus 29. Now, most problems would be done, but again, the goal is to get x, not the angle itself. So, we know that the measure of angle GFH is 59 degrees. We just figured that out. And we also know that it is 11x plus 29. And this is just because the problem told us it was. Since both 59 and 11x plus 29 are equal to the same thing, they have to also be equal. There's no other way it could be. So since these are equal, we have 11x plus 29 equal to 59. From here, we solve our equation like we're used to doing. So we need to solve for x. So first we need to move the 29. I'll do that by subtraction since this is addition here. This cancels, leaving just 11x equals 59 minus 29 is 30. Lastly, we need to divide off the 11 on both sides. X equals, I think this is going to be 2 point something. Okay, and for this one, round to the nearest 10. So, tenths place. The tenths place is the 7. So 2 is not big enough to bump this up. So 2.7 is our answer. So x equals 2.7. And we are done. That is all for this video. These examples go with the homework assignment on Delta Math. They actually are Delta Math examples, so you might look out and get one of these exact problems again. Feel free to obviously use the notes on that. But hopefully this is enough to get you started and to give you the help you'll need if you get lost or stuck on any of the problems. If you have any additional questions, please feel free to ask me either over email or in person. Otherwise, you have a wonderful day. Bye.